presentation must be high focus, highlighting the what are the attributes in terms of the 4-5 parameters, and that you all are aware about these parameters, and innovation and originality, then feasibility and practical implication, relevance to civil aviation, impact and value additions, and that should reflect while doing the presentation. We will extract this, but it will be better that from your side, I think you should focus on that. That will be good one. So now I request that we will be now start that team.
So a very good morning to everyone present over here. A very warm welcome to the respective jury members, senior government officials and dear students. Today we are gathered here for an exciting and intellectually stimulating event, the Civil Aviation Innovation Challenge. A student competition to encourage young minds to innovate, ideate and contribute solutions to the evolving aviation ecosystem. This challenge is designed to inspire creativity, problem solving and practical thinking, giving students a platform to showcase their ideas that can shape the future of civil aviation. Before we begin the competition, it is my honor to introduce our esteemed jury members whose expertise and guidance add immense value to today's event. Professor Raghunath Singh, Vice Chancellor, RJNAU, Dr. Archana Heber, Senior Scientist, National Aerospace Laboratories, and Mr. Manish Sinha, Chief Executive Officer, Amaze Aviation. We are truly grateful to all the jury members for taking time out of their busy schedules and to be with us today. A big round of applause for all the respective jury members. Now let us move on to the competition. The Civil Aviation Innovation Challenge will be conducted as per the following rules. Each team will be given a fixed time to present their idea. The presentation should clearly cover the problem statement, proposed solution, innovation, and feasibility. After the presentation, the jury may ask questions. Teams are required strictly to adhere to the allotted time. The jury's decision will be final and binding. We request all the participants to maintain decorum and wish them all the very best. Now let us begin with the presentations. So I invite our first team, Air Sathi, to kindly come up to the stage and begin their presentation.
First of all, I would like to ask if I am audible.
Absolutely.
Alright, thank you so much. Good morning, respected jury members and everyone present here. We are Team IIT Madras and we are here to present our solution to the Civil Aviation Innovation Challenge 2026. Myself Ridyansh.
Myself Mayan.
And I am Manidatta.
So,
Which year student?
so we are currently in the 4th year of mechanical engineering, final year.
Which branch?
Mechanical engineering, all three of us. So, India is a rapidly growing civil aviation market and currently ranking 3rd globally in the domestic civil aviation market. But even after achieving so much, there are some fundamental bottlenecks in the system. These problems for a passenger who just wants to travel from point A to point B, he has to scour multiple information sources such as display boards, check-in counters, help desks, etc. to find the information he is looking for. This basically creates a cognitive load on the passenger and induces anxiety, especially for the first-time flyers. Then coming to the infrastructural part, I'm so sorry. Coming to the infrastructural part, there are two main problems. The first one being most of the touch points with the passenger are physical instead of digital, and most of the upcoming queries by the passengers are of very routine nature, which can be solved using simple LLMs. This basically leads to unoptimized resource utilization. So, why hasn't the industry, focused on passenger experience when the airports themselves have scaled a lot? there comes three main pointers to reason with this statement. The first one being there exists no unified passenger intelligence layer over the airport and the airline. The second thing is most of the information flow from the airline to the passenger is manual and it is very reactive in nature. And the third and the most important part is that airports have scaled for operations and airplanes instead of the passenger. So today we will be focusing on the passenger experience first. That is why we are introducing Air Sathi, your personal travel concierge. Now, before the airport is when the stress starts to come for a passenger. At the terminal it rises, and at the gate it is at par. So Air Sathi will be there with you throughout the journey. Before the airport, it helps you prepare for the flight, booking, pre-flight checklist, arrival assistance are some of the aspects that we'll look into. Inside the airport, it manages all the notifications and helps the passenger to go from the entry point to their gate. And at the gate and beyond, it manages all the critical updates such as any gate changes, delay notifications, or in the end, after landing, baggage claim as well. Now, Mike will be going on with the features.
Now I will discuss the core features of Air Sathi. First of all, Air Sathi provides a flight booking facility where passenger can search and initiate their flights. Then here we used WhatsApp that is used by millions of people in India, and like every person is familiar with WhatsApp interface. So like after booking ticket, it will help them with pre-flight checklist, not in a theoretical way, but by giving them AI generated images and videos like what to pack and what items are allowed or not inside the base, so that they do not packing at the airport. The next feature is arrival assistance, which recommends an appropriate airport timing, like when to leave from home according to their city, like what traffic conditions are. Then comes the check-in and security, and like it will guide them with check-in procedure, what to carry and what to not, so that they do not panic, and guide them from entry to boarding. The next core feature is real-time updates. Like it will notify them if their flight is delayed or gate has been changed, where to go, and much more. And even after the landing, it will guide them like towards the belt where they can collect their baggage.
Good morning. Now I will show the prototype architecture we made to show the feasibility. The core is that we are using a fast API server. Fast API is a tool popularly used for building microservices and APIs. It will be handling the flow of data, and it has clean endpoints with APIs and webhooks. Then we are also using the Twilio, which is a message service provider, and it gave us a very fast way to connect with WhatsApp, the user's WhatsApp, and also receive incoming messages, and basically webhooks and APIs. And also we use the SQLite database. It acted as a mock AODB or FIDS, and it will help the mock data of flight info and the passenger info all together at one place. And WhatsApp is the front end for user interaction. So the messages from either from the LLM or like the standard messages or the notifications, they all come to the user. We chose WhatsApp because it's pretty widely used, and especially for like people from tier 3 or cities, or since we are trying to expand more towards them, it is easier for them to use. And some of the key metrics that we can judge our project if we scale it up is like the reduction passenger uncertainty and anxiety, and also reducing on load on the manual health tips, especially during peak times when the chaos and the noise even leads to higher anxiety with the passengers, and then also decrease in missing the gate and boarding updates. Because there are multiple announcements going, and there are like more even like the airport terminals at the major cities have gates numbering into hundreds, And also improvement in the information delivery services. Routinely, people miss multiple gate change delays until the last minute, which this can delay. Yeah. Now we'll show a demo link to show how it can be and how our prototype works in practice. If the moderator can click the link at the resources.
Integration, have you checked with the integration of this? That is one of the most important. Have you checked with the integration of this all database you are taking? How your approach is going to integrate that also?
So one practical example that we can give you and we researched about was how in Delhi you can book a metro ticket on WhatsApp. This is a new feature that they have introduced, and this includes the WhatsApp chat interacting with the database of Delhi Metro as well as your UPI and like WhatsApp as well. So that is like one thing that we have taken
If you
into
want to
consideration.
implement with that is a airport, if you are looking at the airport, airport has also so many softwares are there, so many things are already happening. So is it any, I think, way to integrate directly to the database rather than deriving from the other source? Is it possible?
So like already at the Hyderabad airport and other airports, they are experimenting with like AODB, the all operational airport operational database, which will contain all the flight and passenger info at one place. So we can easily integrate with that, and then we just needed to.
And this is last question from my side. What value additions that will be if compared with the innovation and originality? What value additions that you are going to do? Very quickly, last question from my side.
Value addition as in like.
Value addition as
Okay.
compared to the existing system.
So like right now, how the passenger receives info and how they go from start to finish, it all depends upon which airline they're booking it. So if it's Indigo, it's one platform they have to, and if it's something else, they have to use a different platform, whether it's SMS or email. So we just want to unify that and make the passenger experience nice and regardless of what airline or what state they are in. Also, this can be scaled up to different languages. So regardless of where the passenger is going to or traveling from, he can do it from the comfort of his language of choosing.
Similar doubts in the same line. Like how do you predict? Are you predicting any arrival times? How do you predict it?
This is something we said, like just how Google Maps shows you a prediction how long you take from your location to depending upon the traffic conditions, right? Similarly, we can predict regarding
Flight
the
arrival times?
flight
You
arrival
take
time.
from ITC.
So this is a passenger first solution that we are developing, and we are not predicting or interacting with operations at like
Okay, so
at
if
all.
you are saying passenger this thing, how is the, are you predicting the congestion in the security lanes, something like that?
Currently, we are not, but we can. I can see over there. And one more thing
Because
is
you will
the
have
first.
lot of data issues in whatever you have told, I could understand.
Right now, our first focus is getting the data, whether it's a flight delay or whatever information is. Usually, when you are boarding, that information to you arrives like from like 5 minutes to even 30 minutes late to you by the time you get to know. But the passenger itself has to go hunt for the data, like hunt for the information. He has to go sit at the board, or he has to ask like what is happening right now.
But now we are getting from airlines, we get WhatsApp calls.
Yeah, and the same thing, right? It depends on which airline you're using. It's not uniform. So first focus is uniform, making it uniform, and also getting it the info as soon as there's any change, the update reaches passenger immediately. That's the what we're focusing on first.
And further clarifying the query, so we can use a very simple logic to like help prevent the overcrowding that is happening at the airport. We are not exactly predicting it, but our logic can help, and if we are successful in delivering this information correctly to the user, this will reduce the load at the airport.
One final thing, you are telling 30 to 40% anxiety is reduced. How did you arrive at those
So
percentages?
basically, there are some supporting factors that we have considered. So how much, basically how much load there is at peak hours. So like mentioned in the PPT as well, 2 to 3 times at peak hours, and then 70% or 80% of the updates are missed through the announcements. So we took a very generous like guess of like out of those 70 to 80%, we'll be reducing around 30 to 40% of that.
If I may add to his point,
First of all, I'll commend you that your architecture part was really good. I think that is something which is commendable. But there is an essence of some missing elements in terms of data which you feel is not available. Today, airports suffer with isolated data. There are data available. AODV came in India way back in 2007, which we call Airport Operations Control Center. And then predictability enhancement tool is already available, which is Airport Collaborative Decision Making Platform. Globally, it is utilized by all the airports, where right from before the pre-departure of the arrival aircraft, the prediction is given for how the departure aircraft from the other city would go. So tools are available, but it is not getting implemented because there are a lot of inter-agency communication required. Airport is a multi-agency, where a lot of agencies work together. And the challenge is to extract data from independent agencies because every agency has got. So that barrier would have, I was looking forward that how would you address those barriers? But good attempt, thank you.
So the video is ready. We may continue with the presentation.
Me and my team, Stack Underflow, are going to present our findings on a problem in India's aviation sector and propose a solution for the same. India's airport sector has been growing rapidly, but operations still remain reactive. Today, congestions are handled only after detection. Staffing is done manually, and congestion is handled based on experience and not data. This results in increased overtime costs, long wait hours, and inconsistent passenger experience. The problem isn't infrastructure, it's the lack of a real-time predictive operational intelligence layer.
So we propose a AI-driven airport operation intelligence platform that actually gives you a visibility of every passenger in the airport in each zone. And apart from that, you also get a short horizon prediction of the surging crowd which may emerge after some time. And apart from that, you also get a confidence-based operations decisions. What decisions you should take if the surge might happen in the future. That is given by a special model from our side. And after that, the code is the solution is so modular that it can be adapted for each kind of airports, be it metro, be it tier 2, or be it UDAN or regional airports. And our solution works in a closed control loop that is very visible at the bottom of the slide. That says a perception. The first block is perception. Then we have a prediction block, and the prediction block goes in a control block that gives us the suggestion what we should be anchoring if that prediction actually gets correct. And then that goes in a feedback. So that closes a closed loop.
So the foundation of our system is operational on-ground awareness. So using CCTV feeds, sensors, and flight data, our system will generate real-time heat maps of passenger densities, queue growths, throughputs, and utilization across zones like security and check-ins. This will help the airport's duty manager to predict and sustain the search based on data and not guesswork.
So visibility is not enough. We actually need some actions to be taken, right? So what our system do is it continuously monitors the staff that is required at a particular zone with the actual number of staff which are actually present. And that same goes for the lane operations as well. How many lanes should be open or closed? That is ultimately detected by our system. And apart from that, our models work in a 3-layer system, as I stated earlier. The perception layer basically takes a live video stream from CCTVs and it gives us the zone matrices. And the prediction layer actually forecasts the future term loads which may be emerging. And the most important, the MVP of our solution, there is a MPC block. MPC is a concept derived from electrical engineering actually, and we tried to use it as an AI field now. And what we did was, the MPC stands for Model Predictive Control. That's a control algorithm. What we wanted to have was, we had a constraints, and that constraint is being minimized so that the loss function is being minimized, upholding some constraints. And that gives us the optimal staff position and staff numbers and the lane opening and closings. And this eventually ensures that our staff and the lane opening and closings should remains as it is, as required, and it very much parallel to the demands currently.
Yeah. So we know, right, the third feature that we are going to discuss is zone analytics and predictive congestion insights. We know the airport is divided into different sections, be it the security check-ins or the baggage, etc., right? Now, what our model does is, first of all, it gives us insights of how many passengers are present on different zones, what is the queue length, what is the wait time for the passengers and everything. Apart from this, what our model does is, first of all, it predicts. It gives 30 to 90 minutes of prediction of the future of how much the congestion will be in the near future in that particular lane or in that particular zone. That's what our model does. And apart from this, it also gives a confidence score so that the operator who is operating the model, he can understand whether that particular insight is legit or not. The fourth feature that we have is live feed. That is basically what I said, that airport is divided into different zones. That's why we have CCTV cameras everywhere. That's why from there we can take the CCTV footage, put it into our model, and through that we can get the data that we require, the passenger, the number of people that are present in different locations, the queue length, the wait time, that all can be derived from these particular data. And in this particular case, since we can have density maps created in different regions of the zones, so that if there is large congestion, the passenger can see that yes, there is more crowd there. The fifth feature that we have is surge and incidents. Basically, if there is any zone that is breaching a SLA agreement or so, then the model can give a insight or recommendation whether what can be done to rectify that particular mistake.
So I'll walk you through what actually happens during a search. In a typical search case scenario, the system generates passenger densities and takes into account flight clusterings and gives this well in advance, like 45 minutes. Now it helps us predict SLA breaches and explains the main root causes of this surge. And as Vineet said, it also recommends staff and lane optimization, which shows the average reduction in wait times. So now we mitigate the congestion before it actually hampers passenger experience.
For the hardware deployment, we have divided the deployment strategies based upon the airport types. For the metro airports, we are heavily dependent upon the cloud and edge hybrids. And for tier 2 airports, we are edge heavy with cloud assist only. And for Udan or regional airport, as there will be a connectivity issue, there can be a connectivity issue. So we are only depending upon the edge only devices. And for the rollout, we have planned it in a 3 phase. First would be the advisory, where we will only get the suggestions. And the second phase would be assist phase, where you will get the one-click buttons, one-click actions. That could be like a staff rebalance. If our model says that you don't need these many staffs at a particular zone and these are allotted, so you will have a button that will eventually distribute all the people who are in surplus to the other zones which are in loss. And the third and the ultimate idea of the whole thing, whole PPT was to make it autonomous so that AI does it everything for us.
Yeah, so now we can go to future enhancement from the passengers POV. Basically, we have 2 features for the passengers. The first feature is passenger navigation and indoor mapping engine. So our system shows the complete map of the airport. The airport is divided into different zones and each zone has a congestion level showed, right? That it has some readings based on color, whether whether the crowd is more there or less there, right? Apart from this, we have AI-powered routing and guidance assistant for the passengers. If a passenger wants to go from point A to point B on the airport, our model gives the shortest distance from point A to point B and in the shortest possible time. As well as what it does is, if there is any disruptions, basically if there is any flight delays or if there is any change of lanes, then what our model does is it adjusts accordingly, both in the map as well as in the routing system. Apart from this, we have impacts on metro airports as well as Udan and tier 2 airports. The impacts that we want to tell is the same on all these airports. First of all, it will reduce the queue lengths by a large proportion. Second of all, what it does is it will reduce the staff overtime in different airports. And third of all, the passengers have easy navigation through our system. So
This was the cost function I was talking about in the MPC. This is what we are trying to decrease. Yeah, that's all.
yeah, so in conclusion, we would like to tell that India's airports are expanding on a much larger level, but without intelligence, it's just operating blindly.
So we are giving the vision so that you can operate smartly.
So now we'll show the prototype that we have built based on everything that we have explained so that you can get a clear idea of what we have built.
We'll navigate through your as a user for the first time users for our website.
Yeah, we'll navigate as a airport manager.
More slide as you have given to the Asmat.
Sorry.
You have more number of slide you have added.
Yeah, actually that was done when appendix doesn't count. We are not presenting appendix. So I just wanted to be clear with the cost function because I wanted if you might have a question.
Limitations and the same framework can be given to all that will be.
Yeah, actually that was not
So
presented.
now I think a good problem that you have addressed. Have you checked that this with the real time data?
Actually we
Some,
did.
I've been checking you have done. I'm not talking about the airport.
Yeah.
I'm talking about any other real time data that you have checked it and demonstrated. And
We actually needed a whole
doesn't
series
reflect
of.
from your. Okay. Please go ahead.
Yeah, we actually needed a whole series of video CCTV camera footages in order to like train the model and execute it, demonstrate it properly. So we'll be needing an access of CCTV for like 3 months of a public space, and which was not easily available. So for the time being, if you might go to the live feed section.
Okay, I think you complete that, then we will take up.
Yeah, so for the time being, what we, for the prototype basis is, we used AI generated video because we were not able to get a public space CCTV footages, stock footages basically, of a time series, like a time series videos. So we used an AI video for that. And apart from that, if you go to the overview of the page, that is where you land actually, on the first, when you actually go to the website for the first time. This is what you see. So in that website, you will get the total of the people in the terminal right now, and you will also get the, for the easy analysis purpose, we have changed the color of the heat maps, terminal heat maps, based upon the how it is how crowded it is actually, and you will also get the zone summaries based upon the colors, and you also get the AI recommendation that was from the MPC I was talking about earlier. You basically what is happening is S5 need to be open because our model is totally predicting that there is going to be a surge in like 90 minutes. So you should open the S5 which is currently warming. So this was the AI suggestion, and you also get the upcoming departures as an airport manager at the same screen. And for the live feed, this is when you actually have this software, you don't need to have an additional CCTV software. You don't need the security guys to like go through the every camera's aspect in the separate software from the camera company. We actually can see the same thing from here itself. And in the toggle menu, you'll change the camera. Yeah. So for the time being, we didn't have the proper videos of our public space. So we used just 3 AI generated videos for the time being, and you can switch between them. And for in the third feature, yeah. So this is the zone analytics. Sorry, this is the staff summary. Actually, what is happening is our model is also giving you how many staff is needed at each zone at a particular time. So as you can see that main entry all is kind of understaffed, because the number of required people are more than the number of people actually present there. So we have to appoint somebody here. So we can actually change the actually shift the people who are in food court to appoint their duties in the main somewhere which is understaffed. And you can also see all the lane statuses here right now in the same page. And the orange lane status shows that it is currently warming, and you can open it if you want, if the surge is actually going to happen. And for the fourth feature, this is zone analytics, where we are trying to predict the waiting time at each zone. The left graph is for 90 minutes. The right graph is actually for the 24 hours. It is predicting for the 24 hours. And you can easily see all the surveys, staffing status, all the status of each zones. And you'll also get the current wait time. You'll get the average wait time throughput, what is happening, what is currently going on. And for the last features,
It's okay, I think you are done.
yeah. So this is the last feature.
Let us take a question.
Yeah.
Okay. So now the last question I asked from the other team, that is regarding integration, because so many things we are making in isolations, and then integration is happening very problems, and then finally we come up with the solution, but we don't use it. And this is a scenario, and even your that will be now that development that not allowed to integrate with others. The others also don't allow it with that because of reasons you well know.
Yeah.
So now you just a very specific question, that whether you have developed the code for this or you have used AI and other things.
Yeah, actually we have used we did code everything from scratch, or we didn't train the model yet because we didn't have the
So
data.
what about there is a provision for customizations also then?
Yeah, actually this is very modular. We can change it for any airports. We initially planned to make it for Delhi, but due to the short time we were given for the prototype,
So
we only made it for Lucknow.
can you show me the source code that now you have?
Yeah, actually that would be in my.
You have not brought it.
No, actually.
So now I think I will pass on to the other question. What is the technical viability? Whether it is going to be viable, that now idea is good. I'm not saying that his idea is good, it is relevant, and it's also need of the hours also. But I'm little bit worried about the technical viability.
So,
Can you comment, very quick comment that is.
what I think right now is the whole idea of our software is just to integrate. Because we have a lot of data is everywhere, but that is very discreetly not managed properly. So our idea comes from, we gather data from all the places and we show it very beautifully to the airport manager.
Thank you from my side. It's a very good concept, let me say, and very much implementable also. Provided you are given the right data to try out in
Yeah,
your
that's all.
concept level. So apart from camera feed, any other data source?
Yeah,
are you-
actually for prediction, as I said, the first perception layer takes the video feed, right? That gives us the count. That along with the flight information, which flight is coming next, is that flight delayed? Is this public holiday? And every like it has like 5 or 6 sections, like 5 or 6 arguments which it takes the function. Basically, we are using an LSTM plus XGBoost ensemble model. It actually, the features we take is we can actually like takes the airport the flight departuring next in the 30 minutes and stuff like that. All these will be encountered by XGBoost and LSTM together to get us a predicted count. And then that predicted count goes in an MPC block, and then MPC blocks actually gets us the what should be the optimal thing we should actually do right now.
Okay. And for the prediction of these conditions, as you was asking the other thing also, how old is your data? Like how much duration of data do you use for prediction?
We actually don't have a data right now, so we didn't train the model yet. This is a simulated data right now. Because
Yeah.
we actually
For the
needed
simulated data?
yeah, for the time being it is simulated, because we actually need like a year or so of video footages so that we can actually train the model on a real life data. And if the airport authority would might like a
Because
solution.
these lean periods, all this, you can simulate only if you have a longer data.
For
So
like
is a model capable of that?
yeah, our models is very much capable of that. As much data we'll get, the prediction will get more smoother and more better to the real life actually.
Yeah. Thank you.
Thank you.
Well, gentlemen, you had a very precise problem statement and innovative as well. One thing which I felt missing, see, we were talking about passenger experience. The entire team had been talking only of manpower deployment, shifting of people. Will shifting of people create experience?
Well, actually, what is happening is the same architecture pipeline is being used to make the future enhancement which we discussed earlier. We can easily use that same data as if some zone is getting crowded. We have predicted that zone is getting crowded. Then we are trying to, we proposed was we'll make 2 different apps for 2 different people. We are gathering 2 different people. The airport manager he'll effectively manage everything, right? So optimistically manage. And another part was where the passenger will actually get these informations that congestion is about to happen. You should not take the security gate A, rather take security gate B. You will reach your flight destination or gate early.
There is a small mistake which I wanted to highlight. Every process at the airport has got a somewhat timeline set. There is agency like IATA which sets certain timelines for the airlines in terms of how much time it should take for processing a passenger check-in process. There are timelines, not fully, because security is something which is again dependent on what sort of alert it is, but train throughput through the X-ray machines. That is something which we need to take. See, you have dwelled, your software is quite okay, but you had missed on areas which will really enhance picture. The intent should be, are we really achieving those objectives or not? Which is the desired objectives at various touch points. And then that would create experience. Otherwise, pretty good. Thank you.
So thank you team Stack Underflow for your presentation. Next I invite team Audio Beacon, our third team, to take the stage.
Institute of Science and Technology. We are second year students from SRM Institute. We are specializing in aerospace engineering, and our project is about an audio beacon based smart airport navigation and baggage assistance system. Myself, R.S. Sashank, and my two other teammates, Kavya Agarwal and Salila Bhimani, will speak more about this project. Thank you.
So, coming to the problems.
So coming to the problem statement we have actually chosen is large and overcrowded airports in India. So people find it really difficult when they are in a hurry to find their baggage belts and also their gates and their check-in counters. And this sometimes may even lead to the missing of flights due to navigation. So the worst part is GPS fails indoor. We can't trust on GPS, and for the elderly and disabled people, we can also this is very feasible for them, and the existing solutions, they aren't real-time solutions. So I'm explaining why the current technology isn't enough. When we use the existing solutions like GPS, that works well, but it doesn't work indoors. While coming to Wi-Fi based navigation, it has high accuracy, but it also needs network mapping. And coming to the Bluetooth device, it needs high maintenance plus regular checkups. Coming to the RFID, which is radio frequency ID, it requires heavy frequency. So these four modules are not, this technology isn't enough for building a complete navigation system inside an airport. So the proposed solution we have is an audio beacon plus a mobile app. An audio beacon is a device that transmits ultrasonic frequency in the range of 18 to 22 kilohertz. The mobile app or the microphone of your phone captures the ultrasonic frequencies emitted by the audio beacon, and it gives real-time instructions, and this might also help you with the assistance, alerts and navigation, and it makes guiding your belt, your security much easier. Our idea is simple: making a smartphone into a complete smart navigation system using low cost audio signals. Passing it over to Kavya.
So how does Aeronav actually works? So it's based on a four-step process. The beacon, the audio beacon continuously emits signals, and these are ultrasonic signals between the frequency of 80 to 22 kilohertz. So when these signals emits, these are inaudible to the human ears but completely audible to our smartphones. So when smartphone captures these signals, they decode the ID embedded in that frequency, and by locating the airport location, by mapping it to the airport location, the app already knows where we are. And then for the user, it's quite simple, like see the directions on the app and go through the direction navigation and estimated walking time to the destination. So the key features. So our main focus is to make the travel autonomous, make passenger travel autonomous. So it gives turn-by-turn guidance, which helps people move easily. Then for the visually impaired people and for elderly people, it gives them assistance more nicely and reduces confusion. Then it gives emergency alerts, and these guides in even low visibility. Then the most important part is the baggage belt. We want our baggage to arrive more nicely, and so it helps us to navigate to the baggage belts after our flight lands. So moving on to the prototype video which we made. No, not on the link.
Cover the most crowded parts of an airport first, and then we move on to food, eating,
But
and
Udan, you have mentioned that Udan airports are not much crowded.
Yes, sir.
Very small airports are there.
It's
And
talking
where
with
people
respect
can,
to.
people can easily identify the gate, etc. and others.
Yes, sir.
So, I think preamble you have written that is, on Quran I'm focusing onto that.
Not just to answer, I told it because
No, no,
of network
that is,
issues.
that is all right.
Yes, sir.
And one more question, very last question from my side.
Yes, sir.
Have you developed a software for that one?
Due to the time being, we couldn't develop a software, but we have an app existing.
So you have taken from the
Yes, sir. We are not trying to hide anything.
open source that, no?
We'll use the help of AI for the app, sir.
So AI,
Yes, sir.
AI is doing that.
Yes, sir.
Okay, thank you from my side.
One doubt was, what are the hardware installations? Any layout plan or
Yes.
what is the infrastructure requirement? Any
Basically, the device is actually very compact because it's only a controller and a speaker. And it might need a microcontroller, an amplifier, and a transducer, and also a
plan
power
for any
module.
layout, how far they have to be, what?
You mean the range of the beacons?
Yeah.
The range of the beacons is accurately 3 meters to 4 meters per beacon. So, but the thing is, when you're walking, right, in the app, it is designed to give directions which are minimum of 10 meters. So if you have to go through a point which is a right turn, it's going to say you have to walk 10 meters and take a right. And within that 10 meters, even though the range of the beacon is only 3 meters, there's going to be another beacon. So there won't be any problem with the range issues. There's not going to be anything about the range.
But all over the airport installations you're planning to?
We focus more about that on a PPT because for now the main focus would be to install it only on the crowded parts such as the security gates and the baggage claims and entry and exits. And later on we'll focus more about where the washrooms are, where the lounges are, because that also comes under passenger experience, we believe.
And any health hazards because of this?
No, we had a doubt whether about the dogs stationed in the inside the airport.
Yeah,
We
you
clarified
should
it. There's
consider all
no.
that also as part
Yeah,
when you're
yeah.
making it.
There's no health hazards for this.
In fact, I echo the same thing. These beacons range is something which is a bit difficult for the airport to install. 3 meters, 4 meters, 5 meters. With a double ceiling height, installation is a big challenge for the beacons. This is very helpful. You have actually touched the right point where for the physically challenged, especially people could not see. There is something which is very, very good thing to have, but it gives them a lot of confidence and independence to walk. They don't require support with the beacons. But installation, you should have looked into. It's very, very big challenge.
Yes, sir. The beacons. Yes. Video ready.
In large airports, passengers face navigation issues. GPS doesn't work indoors properly, and signage is often confusing, especially during gate changes and baggage claim. Audio beacon installed at checkpoints. For this prototype, the audio signal is transmitted using a speaker-based beacon, and detection is done via the app using the phone microphone. The app listens to the environment, applies FFT-based processing, detects the frequency pattern, and decodes the beacon ID to determine the user's current location. Once location is detected, the app provides real-time indoor navigation with turn-by-turn guidance. For baggage claim, the app guides passengers to the correct belt and can display baggage arrival status when integrated with airport systems. This prototype demonstrates a low-cost indoor navigation and baggage assistance system that works without GPS and supports inclusive smart airport operations.
Thank you, Team Aeronav. Now I call upon the fourth.
We are in final year and pre-final students from IIT Gandhinagar, and we are here to present our solution for air traffic management modernization. Globally, drones are going from experiments to reality, and in future they would be extensively used in last mile delivery, logistics, medicine, and emergency response. and in drones globally have a market size of $73 billion and would be heading, and it is heading towards a $160 billion market. However, India only has hasn't even captured 1% of that, and therefore we are here to given the given that we already have proposed mission Drone Shakti and Drone Rules 2021 and National UTM policy framework, we are already ready with the policy. We just have to come up with the architecture to integrate the drones and perhaps in the future, so that their management there's a proper architecture in place for air traffic management of our drone reality. So our idea is called Project Akashmar. Yeah, so we want to like India would be transitioning from air traffic control to air traffic management. Currently, most of the aviation in India is manned aviation, and that has been done manually. We have air traffic controllers that handles like thousands of flight operations. They pilots ask for permission, and then the ATC gives the approval, and then everything is controlled manually. However, in case of drones, that would not be the reality, as drones would be operating in the urban canyons in metro cities like Bangalore, Mumbai, Hyderabad. Therefore, we have to come up with a different architecture. By starting 2030, when India becomes a Viksit Bharat in 2047, there will be multitudes of drones operating in our cities, perhaps especially in the e-logistics and different use cases. And we have startups coming up in India that are focusing on that, development of drones for delivery, and perhaps there are attempts for air taxis as well, and it is being doing, and it is also being attempted globally. So we are here to present our idea, a vision, that helps India to be a leader in this and build a complete new architecture, just like UPI, or just like we have done a revolution in the telecom sector. We want to propose this such that India takes a leapfrog and puts forward an architecture for our drone reality. Now the current issue is that we are relying on the legacy infrastructure that is bound to collapse. As I mentioned, there's a scale mismatch. When drones become a reality, our current ATC system would not exactly be able to handle that. Thousands of drones in the city landscape, the urban canyons. We need a simultaneous complementary system that complements the current ATC system, and they work cohesively together. The urban blind spots, so our current legacy radars like PSR, SSR rely on line of sight visibility thing, and the current use of GPS would not exactly enable the movement or navigation or perhaps coordination of drones in the urban landscape, and there's no role of ATC. There's also a connectivity gap that the current, the 4G or the 5G bands that we operate on would lead to latency, and latency would kill if we have thousands of drones operating in, let's say, 2047 in India in the urban landscape. A blind spot, or let's say our error of 3 meters would be significant, because these are unmanned systems, and if we compare it to cars or manned systems, that error is manageable. But drones that are automated or unmanned, we won't take any chance. Now coming to the solution, the main part of the main thing, the architecture that we are proposing. So it will be a 3-layer system or architecture. The first layer, that there would be a flight information management system. It would be managed by DGC or AAI, Airport Authority of India. So they will be the ones who will be simply coming up with policy or regulatory frameworks. They won't be managing everything, or they won't be overseeing it. Then layer 2 comes to the USS, the US service suppliers, basically the private players who would be actually operating these drones, who would be actually involved in the these services like delivery services, or let's say medicine delivery or emergency response. Just like telecom, government sets the regulations, and and these private players, they operate the exact system. We'll have these private players handling the US, or they'll be the basically service providers. And then the third layer is the discovery and synchronization service. So we are suggesting use of protocols or APIs that enable peer-to-peer communication. Just like we have in place in ONDC, or let's say we are coming up with open networks in India. For example, I forgot the name, but we are also coming with an open network in agriculture, and there's already a ONDC in place. So there we are using open protocols that actually enable peer-to-peer communication. So we'll be having a system in place wherein there won't be a mediator exactly who will be relaying the communication between these unmanned vehicles, but just a system where there's an entry point, and then these UAS or service providers can handle the drone to drone communication. Now my teammate would explain, go into the technicalities, what are the things that we are suggesting to use. For example, NAVIC and 5G network slicing and other things.
Alright, so now let us understand that how we will do the navigation of these drones. So the first and foremost intuitive thought comes to our mind is let us use GPS, which is already very well renowned in the world. It is also integrated with many applications, so why don't we just use that? But there are some serious issues with the GPS. Due to those reasons, we can't use it for the operations of drones. So let us understand what are these errors. So first one is the multipath error. So if we talk about drones, so they would be operating in urban cities such as Delhi, Bombay, Hyderabad. So they have very high-rise buildings, very narrow streets, fairly congested areas. So GPS signals are bound to collide with these towers, the mirrors of these buildings, and can cause a multiple signal effect for the receiver antenna. So the antenna cannot be able to successfully with high accuracy able to distinguish that whether the signal is coming is original one or the collided one with buildings. Then second is ionospheric delay. So Earth has this around 500 kilometer range of atmosphere above the 550 kilometers of above range. So in that ionosphere there are free ions which are formed due to the solar radiations. So while communicating with the satellites for these navigation based reasons, these free ions cause delay as they change the refractive index. So these is also serious issue with the GPS. Then comes the low elevation coverage. So GPS is meant to be for global thing. They are not India specific. So for to tackle these things, we come up with the idea to use the NAVIC, which is our India's own satellite-based system for the navigation. So NAVIC have several benefits over the GPS. The first one is S-band signal. So NAVIC currently operates on 2 bands compared to GPS, which operates on 1 band. So due to these using of 2 bands, the ionospheric delay error could be eliminated, and the penetration into deep urban cities is better compared to GPS. Then comes the high elevation orbit architecture. So NAVIC satellites are focused above India subcontinent only. So they have again the better penetration to these rural areas as well as the urban narrow streets. And then as I talked, the dual frequency ionospheric correction, so that is achievable through NAVIC, while GPS relies on modeling based system, while in the case of NAVIC we can actually calculate the error and remove it.
If I may ask the team to wrap it up quickly, as we are running a little short on time.
Then we have the other part of technical pillar of the solution, which is 5G network slicing. So for these drones to operate, we need very ultra low latency digital communication. So for that, we proposed the dedicated 5G network slice, which is dedicated to this operation of drones, which is able to provide less than 10 milliseconds of latency. And we suggest to use the edge computing instead of cloud computing, because in cloud computing again the data collected from the IoT devices and sensors on the drones, they need to be traveled to maybe 500 kilometers far apart cloud center and then computed, and then the signal is sent back. But instead we suggest to use mobile based edge computing techniques to reduce that reaction time as well within less than 10 milliseconds.
Yeah, so we have heard the solution, but it's also important that where do we stand in the world in compared to these innovations, right? So if we talk about USA and Europe, these are one of the leading economies, and they are also heavily investing in this drone innovation. So right, so talking about what proposed solutions we have. So the first one is the architecture model, that is sovereign federation model. But if we compare it with the US, it is a decentralized model. Right, it has a centralized system, but that is not backed by technology stack. But if you talk about the Europe, it is hybrid centralized because Europe is a union of 27 nations. Each nation has its own parliament. So there has to be discussion among each one of them when new things to be introduced. If we talk about navigation system, as mentioned, we have Navic, while US use GPS and Europe uses its Galileo, the constellation of satellites. The urban reliability, as we are using Navic, it's highly reliable because it's just India-centric. It's constantly, as they are in geosynchronous and geo orbits, so they are only on India, right? And as mentioned about deconfliction method, here we are using the peer-to-peer API system, that is the DSS system, which is better than any other system that are currently, I think is better than any other system present in worldwide. Moving forward, sorry. Yeah, as our solution is also completely aligned with the drone rule that came in 2021. So first is the integration of Digital Sky platform in our system. So as Digital Sky currently has all the data entries of the drones that are registered, the certifications, this can be easily integrated into the system because that will create a firewall around the whole ecosystem. Next is the NPNT, that is the no permission, no takeoff. Like we know we have green zones, yellow zone and red zone, right? Manually operated drones can enter these zones, but if we have Navic and this Digital Sky platform integrated together, drones won't have permission to enter these systems and would be avoided to enter these systems. Right, so we have heard the solution, but we have to also consider what stakeholders are to be involved in this. So first is the DGCA that comes up with the regulations and the frameworks that this whole sector should operate in. Next is AI. As we know that currently airports are in yellow zones, the 8 to 12 kilometer area is done as yellow zones. So we should have we can collaborate with ATC and AI to come up with proper approach. Next is WPCA, that is the wireless planning and coordination wing of telecommunication, where we can coordinate with 5G slicing. Next is the security compliance, where we can differentiate between the drones that have taken permission and not. And last is the ISRO for Navic satellite communication.
You conclude that. You conclude.
Yeah, conclude this.
So finally, this solution. The India needs to be future ready for when drones become reality of our aviation or civil space. And down the line, we have to have a proper architecture in place. And by 2030, several reports suggest that we can unlock an economic value of $23 billion.
15 seconds, please.
Sure.
We have exceeded. We have to be fair.
Yeah. So finally, this idea or this vision solves the scale problem through federation and the safety problem through Navic plus 5G plus MEC, mobile edge computing. And we believe that it would be a very visionary shift from our ATC only to a ATC plus a complementary system that could handle both our manned and unmanned civil aviation space.
Thank you, Team Akash Mark. We may now proceed to jury questions.
So I have one question, couple of questions.
Sir.
That you have basic idea is that you are creating a neural network for Indian sky.
Sir.
But lot of, I think, things coming into the picture. So are you doing this project for some other organization? Already you have proposed phase 1, phase 2, phase 3. What is the phase 1, phase 2, phase 4? What is the phase 8 you have also proposed, not phase 1, that you are
So
going
yes.
for phase 1 2026, then phase 2 in the 2027, then phase 3 28, 30. So
No,
what
sir.
do you mean by this phases, matlab?
So we expect that India should move with agility so that we can dominate in this sector. We are not proposing this for any other sector or for any other thing. So we are doing this for the civil aviation challenge only. So that is our plan. That because the tech stack.
No, I got your point. But what idea you have implemented so far? What you have implemented so far? That is, I think you tell me that is a very briefly. That what you have implemented so far, and then what you are going to take forward in 2027, then 28 and 30 months.
So sir, I feel that tech stack which is required for the implementation of this architecture and idea is already ready. So we need not to make any new thing. We just need the compliance thing done along with different bodies. So For that thing, I think we need to work to like maybe whether this thing should come under the DCG or whether should we need a new entity under the government rules and regulations.
As far as your project is concerned, now there should be a complete alignment of the regulatory authority also, like DGCA
Yes.
as the regulatory authority. So have you, while doing this project, have you consulted the whole people of the DGCA that now maybe I think once you go there, they will also tell several problems to you.
Right, sir.
Then the implementation will be the issue. Then whole idea is gone. So have you discussed while doing this project? Have you discussed with the regulatory authority, because the main component of your now you are targeting to the civil aviation. You require that is a regulatory authority that now. So what kind of problem you face? Are you aware about that?
Sir, we haven't actually consulted any of the real stakeholders. So this is only a idea or vision that we have come up with after doing a lot of readings and articles and things that is already being done by DGCA or AAI. For example,
so this is an open source software that you have used, no?
So it's not exactly a software. So it's like an umbrella ecosystem that needs to come into place, and a lot of you people have to collaborate and then decide whether this needs to be done. We have taken inspiration from the current revolution in the telecom sector, and as well as the UPI that India has built alone.
That is all right. I think that is relevant. Your work is idea is good.
Sir.
Yeah, I feel this is a literature survey, not a concept. DGCA has already come up with UTM architecture. NAVIC is already a part of. You are talking mainly about the CNS, communication, navigation, surveillance. So navigation, 5G communication, other means of these ADSB, all these communications, they are already there, like already planned for the drones. And what is new in the concept, I didn't know, like I didn't understand. U-Space is a Germany, European Union is coming up with a U-Space concept. NASA FA is working on the UTM architecture. And DGCA is already in the finals. They have already framed an architecture for it in the same lines. Like, yeah, what is new?
Yes, ma'am. As you mentioned, that NAVIC is already there, 5G is also there. But as far as we researched,
no, it is there for, and already it can be used for drone is already proven, like it is known. So what is new in this? Any simulations you have carried out to say that yes, this works for any simulations are there? Like
regarding mobile edge computing, ma'am, so the research in these areas hasn't been done too much. So currently in US and Europe also, the drones operate mostly in cloud-based computing only. So they can rely on cloud computing because the majority of the world's cloud computing companies infrastructure is US Europe based. But we as a country, we don't have that infra currently in India. So for us, it is strategic as well as the technical aspect wise also. Mobile edge computing is more beneficial for India, which is currently not being done in any of the countries.
any corroboration with respect to the actual numbers, anything is there quantitative wise? Telling this is good, this is bad, this is good. Yeah. So like a survey, did you do any work to say that yeah, this concept works?
Like we don't have a specific testings on the drones, but like for if we talk about the latency, so like it is proven that 5G can achieve less than 10 milliseconds of latency. It is proven in other applications that through mobile edge computing we can reduce the computational time compared to cloud-based computing. So for drones it hasn't been researched well, but for other applications these things have been tested.
So why are you calling it federated neural network architecture?
So through federated we mean that our system would not need to be rely on one single entity. So multiple people would be autonomously, like multiple entities would be autonomously coordinating, and the drones would be functioning autonomously. If I talk about the neural network, so we didn't mean to that AI neural network thing, but we meant that the system is self-capable to manage it as it progresses.
Okay, thank you. That's it.
So now we finally invite our fifth team, NIT Warangal, to.
Just a second. just 2-3 questions. One is, are you considering of combining the current air traffic movement, the air traffic control management for airplanes and drones together?
So, sir, while thinking about the solution, we felt that for the airplanes which are operating at the elevation level of greater than 1000 feet, so for them the current ATC system is well established, and also like for flights, we need to comply with global entities because it can't be only India centric. While in the case of drones, we have like we can function as separate country, but in the case of civil aviation, like in normal flights, we as of now don't have given thoughts about using this.
Fair enough. So you are basically talking about a new thought process for managing drones. It just lacks interaction with the authorities, and having gone through the literatures of what ma'am said, that there are a lot of development which has happened in this area. Perhaps you should have considered and then developed further on that. It's like revamping the entire system and starting afresh. Your presentation, I mean, architecture-wise, thought process-wise, commendable, but standalone. Thank you.
Thank you, sir.
Thank you, sir.
So now I finally invite our fifth team, NIT.
Based ATM modernization, that is basically we are addressing the multi-layer weather data fusion and presenting the we are addressing a problem about weather data. Weather plays a very crucial role in present air scenario and the airspace management. And when we talk about air traffic management and weather-related data, it is a very crucial entity to resolve the air traffic management issues. So what problem we are raising is how to fuse multiple data holding in different centric servers and give to ATC, fuse it to ATC to present a solution for better weather prediction, diversion of air traffic data, and airspace management. So if you see, first we'll see the problem. What is the problem here? If you go to the problems here, recent incidents 2 days back we had an issue. The weather-related issue played a role, but we don't know. But news article says we have to wait for the investigation team to finalize on it. And in 2025 May and 2025 May 2nd and August itself, a lot of weather-related problems have caused various problems in routing the airplanes in different airports. And a lot of casualties were also there, and there are a lot of turbulence issues, hailstorm damaging issues are there. So our area is trying to handle this particular problem through a multi-sensor fusion architecture, which we will be covering in the coming slides. So here we this data for this particular problem, how to address. So we will first present you a weather prediction system to handle these problems. If you see the top right picture, right side of the system, slide, there is an ISRO INSAT satellite data that will give information like to the Indian Meteorological Department, and then it will give some quick feeds like nowcast about the weather data, weather prediction, how cyclone is building up and so on. And so this data goes into supercomputers, and the very nice infrastructure what we have in the IMD department. But the data is critically analyzed there, and they are residing there only. The other part is NCMRFW, that is coordinating the Bharat forecasting system and Mithuna forecasting system, beautiful systems, but data is residing there. And we have already ADSB enabled flights and ADSB enabled ATCs in India. Good, thanks to Government of India, they are expanding day by day these ADSBs. They play a very crucial role in the air traffic management. So all this data, they are there, but the respective feed to the actual ATCs who are on the control of the navigating the flights, holding patterns, which flight to land, to them this information is not reaching. We are addressing this problem by fusing all these nowcast predictions done by the IMD supercomputers, position data that is coming from ADSB, and then presenting it to ATC. So are we disturbing the ATC's work? No, we are not disturbing the ATC work. We are providing a shadow ATC network where the ATC will be operating similar with this current infrastructure. We provide another workstation and a display system wherein we suggest the ATC of a possible hailstorms, possible windstorms, tailwinds, possible cyclone bursts, and mid-air storms. So with this, they can take a decision in diverting these aircrafts and then minimizing the holding patterns. So here we have seen, in this problem, when we have interacted with offline ATC controllers in Hyderabad and in Bangalore through our project teams, we have identified one thing. There is no policy on the how do this IMD, NCR, ADSB data come into ATCs. Policies are not written. Policies are there, but actually implementation is not happening. So what we have is, we are suggesting in terms of policy decision here, DGCA should have a MOU with ISRO, because ISRO has got horrible kind of data where we can see how cyclone buildups are going on. If you see, example in recent Mamta cyclone and Hudhud cyclone, Visakhapatnam ATC has got a lot of requirement of this particular policy to be implemented. The idea is, we will not be disturbing the ATC, but the policy will bring ISRO into picture, and ISRO developed the data. Bhuvan is there. We have to provide APIs and feed that into this ATC servers so that this nowcast can be more intelligent in terms of cyclone prediction. So this, the top left is the cloud concentration in the airports. The picture. This is one part of the outcome that shadow ATCs will be providing, and how cyclone buildup is there, how far it is there, how it will impact the Visakhapatnam ATC and airstrip. That information will be there in the ATC server. The outcome will be finally in this graphical representation and alerts. Coming to the second issue, second problem, dynamic airspace management for busy airports. We have seen that Delhi and Mumbai airports are busy airports, and they are handling a lot of traffic. And the Mumbai airport has got single runway. Even though they have made another airport, the single runway handling by ATCs to divert these planes for landing and takeoffs, crucial things, and a lot of ATC people are having a lot of stress in managing these landings and in the Delhi and Mumbai airports. So what we will be doing is, let's say during this busy ATC interaction with the pilots, let's say cyclonic storm is there, some hailstorm is there. Now what they will do, they will tell the pilots to go for a hanging pattern, and they have to rotate, go around, and they have to land. That is the only solution, or they have to divert the airplanes. Now, the present system, what we have analyzed is, it is not considering the type of the aircraft, whether it is small aircraft, ATR class, or huge Airbus 320 or 787. So for both the aircraft, their diversion pattern and resolution methodology is same. What we are suggesting is, the AI system should take the airplane into picture, the size, body issue, and they have to divert, the diversion radius has to be minimized. So the runway, when it is runway is busy, ATC instructor aircraft are holding the pattern. Then holding is a huge carbon emission. So a lot of fuel goes into holding pattern. What we are suggesting is, and also these diversions, they have restrictions in diversion. Why? Because near to Mumbai, Pune Air Force Command is there. There is a military aviation. They will tell that in our airspace, restrictions are there. So we are suggesting a policy here to formalize the civilian airstrips and military airstrips. They should be having an understanding, so that we will keep the military airstrip as powerful. They are the whole and sword, and they are shadow ATC framework, which is very much implementable. We have discussed with various stakeholders, ISRO and other teams. And one more thing which I want to do is, when we are landing an aircraft, air quality index is very important. We got certain information that AQI.in website is there, which is giving the AQI devices. So when this weather information also have to be passed on to the passengers as to when you are landing, you have to give the AQA information also so that the senior citizens who are flying in this will take care. The outcome is we are proposing an implementable, predictable AI system, which is a shadow ATC, which works and gives it better results. Thank you very much.
Thank you, team NIT Warangal, for your presentation. This brings us to the end of our team presentations. We now request the teams to kindly exit the hall.
Now, I know that you are doing PhD in which area?
Sir, machine learning.
And
Machine learning.
machine. So now, are you familiar with that is the weather prediction? Because the different model has been developed. And so far, my understanding, though I am not a expert of the weather analysis, but we have a regular discussion with our colleagues also. And on that is now the model so far, that is several models are available.
Right.
There is a problem in the modern Mantal and not predicting well Mantal. Your entire idea is based on the weathers and others. And also you have emphasized that currently ATC and others they are using this kind of that. So you just tell me, have you prototype of things, have you demonstrated that this way?
Sir, 15 days we went for survey of various airports, sir. Whatever access we got, we have interacted with them and found out ADC's output and airport duty managers also. What we have developed two missions, sir. We have built two missions, and for visualization purpose, we are using CGM.js to visualize this data. For API calls, sir, what we have done is we have developed one Bhuvan downloadable terrain map with cyclone and cyclone prediction data of August 2025, and we got it from Bhuvan by having the credentials from the NIT Bangalore. With that, we have presented it with the system, sir. So what we did is when the cyclone is there in developing next 90 minutes, predicting.
I got it when the AI predictive and
Predicting.
things are using.
Yes.
But one, I think major concern is that to be whether it is implementable. That is
Sir, it is very completely implementable because this is we are taking the API calls. API calls means Bhuvan website and IMD website are ready to provide API calls, which will be attached to the nowcast. This nowcast data over the period they will get into our database, and the AI algorithms like reinforcement learning, what we are presently she is working on that, and LSTM she is working on that. Both the things are predicting nicely because the patterns in Eastern Bay of Bengal, Hudhud, and the data we got it from Bhuvan, and Ponta, cyclone Ponta, also we got it from Bhuvan. This all both the cyclones prediction, pattern prediction is same, sir, and wind speeds are also same.
Okay, I'm done.
Yeah, you are telling this CCM.js you have used, that is only for rendering. Why did you choose that? Why not insert images?
CGM.js, ma'am, it is web-based, so we can give access to multiple systems based on web server, and the CGM is very lightweight, and in that CGM we can put entities also. We felt it is by giving the actual ADC pictures and entities inside that, and we can pop up alerts very nicely.
It may not be real time, no?
It is because it is web-based. Auto refresh can be used.
US based or something?
No, ma'am.
Where
It
is
is
the database coming from for CCM.js?
CGM.js is a technology. It's a web-based, web server-based framework, which is used for only visualization.
Yeah, that's right.
And we can put.
Maybe you should think of
And we have developed that. We have superimposed in CGM.js the trajectories of various air networks. And so airplanes are movement, and cloud burst in terms of point cloud we have already added. And when the air highways are interacting with these cloud movements, alerts are coming. Till that place we have implemented. And it is very fast implementing. Only thing is it needs a web server setup. As I said, it is along with the ADC displays, one more display we need. That is the infrastructure requirement. Otherwise, it's completely implementable.
One basic doubt is about your understand that already ATC uses IMD data, which again takes from different weather stations. I just noted down radar, satellite data, numerical data, prediction models are there, and automatic weather stations which are installed near ATC. What value addition is there in your?
Our system's beauty is it will not, it will not, what is the present weather condition, it will not say. It will say in next 90 minutes, what would be the weather problem? Because it has the information about that. In next 90 minutes, possibility of this particular aeroplane in this airstrip from Mumbai to Hyderabad is going to collide with particular developing cyclone, and it will give alerts in between, and it also takes decision by with the shadow ATC server of the Vizag that Bay of Bengal one thing is there in 90 minutes it's going to build up very strongly. So diversion possibility.
So 90 minute prediction time you are
prediction
having.
time. We are predicting before this emergency, before this problem becomes emergency, we are predicting these things and solving that.
Good.
You have touched a very niche area in terms of, so I'm very, I would say excellent problem statement. The impact, because see, weather related issues at the time of landing, which you're talking stacking, I really don't know how this stacking will get, what help you will get at the stacking, because stacking is it is not 90 minutes plus. It's a real time stacking.
Correct.
So there it will not have, but en route weather forecast may give me alert, because if the flight is more than 90 minutes, probably I'll delay it on the ground. It will lead to lesser fuel burn. I mean, that was the one thing which I was looking into, carbon reduction. That is something which you should have mentioned. That is one of the advantages which has been missed on your point. You have been very, very, very technical on your things.
Yes.
So carbon reduction is one. The second thing is ATCOs, the load on the fatigue load on ATCO is something which we need to understand. That's what this additional screen would cause, because as the airport grows, and we are talking about bigger airports, mega airports where you are talking about Mumbai, more than 48 movements per hour, per hour on a particular runway. See, that's the place where the fatigue level and how would it really relate to ATCO is something which was missing. Otherwise, very good presentation. Thank you.
For your first point, we have already got information from Vizag airport, sir. Vizag airport is mostly because it is very close to sea. It is affected by crosswind. When landing, there are three types of wind: headwind, tailwind, and crosswind. During that crosswind, we can predict whenever there is a cyclone, how much wind speed is coming. Is it crossing?
So this brings us to the end of all team presentations. We now request everyone except the jury to kindly exit the hall for a coffee break while the jury deliberates and